to be talking about one of my favorite topics, data analytics, advanced analytics, a word that's been around for quite a while. We have three great panelists that are each experts in their fields. Let's start off by having you introduce yourselves. Take it away.
Yeah, nice to meet you all. I'm Håkan. I'm a solution engineer at Neo4j. So as a solution engineer, I try to avoid getting my customers in too much of the technical depth and problems. But I work across all our enterprise customers in the Nordics, so I see a lot of different applications, different architectures. We work with anything from real-time recommendations down to more advanced analytics. So,
all right,
it's a little bit about me.
Yes, my name is Ole Olesen-Bagneux. I am the chief evangelist in Actian. I'm also an O'Reilly author. I've published my first book a couple of years ago called the Enterprise Data Catalog, and I'm just about to launch or publish my second book, Fundamentals of Metadata Management. And as a chief evangelist, I get to talk and speak and write a lot on our data intelligence platform. That's really a complete platform from data catalog to data observability, data contracts, data products, all that you really need at the metadata layer to manage your data infrastructure and push forward with use cases for data such as artificial intelligence, machine learning, and generative and agentic AI also.
Okay, cool. And last but not least.
Hi, I'm Angela. I'm a solutions engineer in Snowflake, based in Helsinki. And been working in data industry for close to 20 years now, so I like to think I'm a bit of an expert at these things.
Seems to be good for your health.
Yes,
right?
100%.
All right. The title of this panel is something along the line of data analytics, a term that's been around for quite a while. I'd like to kick things off. I want to hear as many hot takes as I can. You're allowed to disagree as much as you want with each other. But let's kick things off. You know, I made a little ad together with a colleague for this event. The joke being, is data analytics still a thing? Is it around? And the person said, yeah, AI-driven analytics.
Sure.
Things like that. Right. So is analytics much of the same thing? Or is there anything new to it in the past couple of years since ChatGPT came out and everybody's opened up their eyes to...
Sure,
stuff.
nothing changed. Changed. No, I definitely think that we look into a future where we need to rethink our data architectures, our data management practices, data governance practices, in order to scale data infrastructures to a level where we can actually work with AI. That takes a completely new setup and a much deeper focus on data. And so what hasn't changed, I think, is the fact that data in most companies is in poor shape.
And I would say, so the Snowflake marketing messages, there's no AI strategy without a data strategy. And just like Ole just said, you can't really do much unless there's data there. And at least in my experience, most of my customers are interested in, yes, they want to talk about AI. Yes, we want to have this conversation, but they want to use it to do analytics. So we're still doing the same thing at the end of the day.
Let me hear that again. So your customers want to use AI to do analytics.
At the moment, they at least want to talk about it. So
Right.
It might be like a chatbot to kind of, say back away from somebody having to make a report.
Yeah.
Like a chatbot where you can then in natural language be like, what's the average shipping time of, this company? That kind of thing. So I would say...
The people that want this, are they people that have data skills, or are they new people that didn't have those skills and now feel like, well, maybe I can do things that I couldn't do before?
Good question. It's usually about getting it to the new audience. So I would say the conversations I'm having are the people kind of who are a little bit closer to the data, who maybe do feel comfortable, but they want to make it a little bit more accessible.
I want to get to graphs because I feel like graphs are a computer science thing that are special.
Oh, yes.
But what's neat about democratization is not everybody's a fan of it. All right?
Yep.
You have data people that are like, data's our thing. You're going to screw it up if you do it. Is this ability to give access to more data to more people, maybe through LLMs or through other newer setups, is it a good thing? Is it always a good thing?
I mean, I would say yes. Good thing.
Yes.
Um,
Okay. I think
but
that's
I
a
would
good
say-
start.
Let's do a hot take. Yes. Yes.
Okay.
I agree. Yeah, I agree.
I'm going to go with it's probably a good thing, but it kind of brings up new challenges, like when data is like all over the place. I mean, there's always kind of something that you need to kind of govern centrally. Like you talked about like cataloging and kind of just, I mean, and I talked with someone here before about like, access to data and who should have access to data. Should governance and controls like that be centrally managed, or should that live together with the data? I mean, I think it's like, it's just how it is. And I mean, depending on your strategy and how you do it, there's you're gonna move problems around. That's how it's always been. It's like trade-offs. It's like,
Let's get back to you now with the first question, which was, has Gen AI stuff changed the way people ask for analytics or think about it or approach it and that kind of thing?
yeah, I think it definitely changed people's behavior, but I'm not sure if it has changed that much, right? It's like, people ask different questions and have different ideas, but in terms of evidence of what is working or what is actually rolled out or deployed there, it's like, I think it hasn't changed that much.
Yeah.
It needs to change more. It's like, but the questions, the ideas people get, the innovative, creative uses are definitely flowing these days, and I think we need to leverage that. It's like energy, interest, and also access to budget is like, those are critical components to make any data project successful.
Yeah. I feel like we can always talk about data catalogs and stuff like that, but that's boring. Because,
Important,
you get the plumber.
old-fashioned, but important.
It's important and old-fashioned, but I'm an artiste. And one of the coolest things that we can do now with LLMs is extract data in ways that would have been insurmountably tedious in the past. So things like creating knowledge graphs and that kind of stuff, which would have required precision work, understanding of how to develop a good ontology, realizing you messed it up, doing it again. Having that all automated with agents and LLMs opens up a new kind of analytics that I'm very excited about. Extracting data that wasn't really mineable in the past because it was in an unstructured format. Maybe now you can turn it into tables and actually do analytics with it. And so I feel like there's this big dark shadow data that's suddenly becoming accessible thanks to LLMs as input methods. Have you come across customers that are using LLMs for data curation and that kind of thing? Yeah, what are your thoughts?
Yeah, I wanna chip in here because I think you're pointing to something really interesting and obviously correct, but I think there's a detail that needs to be stressed here. When we're talking about ontologies or graphs and large language models, all studies, science, pretty much in general, points to the fact that using ontologies, using graphs to enhance LLMs works really, really well. And the opposite approach does not work very well.
Which is the opposite approach?
The idea that you could somehow generate an ontology based on large language models is a little dangerous, and I don't believe in it.
Or
And
you
I don't
can,
think you-
but you don't get good results.
I have not seen any studies indicating that would be possible, and I don't think it will ever be possible, but because it defies the nature of human language that is, in essence, dubious.
Yeah.
You need a clear graph, a clear ontology to really make your large language models performing better. And studies show that is totally possible, both in terms of coding, if you want scripts, but also in terms of like generating text from coding. So that it works both ways. So I'd say, yes, I see exciting opportunities with large language models, with generative AI in general. Like that is a cool thing. But I wouldn't argue, like graphs are also very, very dear to us. And all the studies and scientists that we follow would disagree in the fact that you would be able to use a large language model to generate an ontology.
And
Challenge
I think I would,
accepted.
I think I would agree with that statement but however, I think they can be helpful You don't have to start from zero. So let's say, for instance, you have, let's say you ask an LLM, like, I want to kind of understand how resilient my supply network is, or my supply chain is. What would be a good model to represent the information? It would probably come up with some idea and of what the model could look like. But I don't think it would work, like you say, like if you had like data like in like random documents and just like have the LLM come up with what is the terminology and ontology used in this document, in this corpus. It would probably just be it would kind of be too influenced by the document rather than looking at what is the application of that model, what is it going to be used for. And in the end of the day, I mean, me coming from a graph database company, I work with all type of data structures. I love documents and tables just as much. What model you choose is probably because of the application you have in mind and how you're going to interact with the data. So I don't believe that there is like a single model that you can come up with that is going to solve for everything, and that's why I also think that an LLM would struggle to kind of extract the model itself. You need to ask other questions then, or instruct it somehow that I'm actually I want a model where I can answer this type of questions, or where I'm going to apply it in this way.
Let's say, I mean, the best use of AI is for stuff that you're bad at, and it's not going to replace an expert, which is sort of an interesting way of thinking about. So in the sense of like using LLM-based AI to do the stuff, like fill in the gaps, is a much kind of like better use. Then use your experts to set up your ontology, as you said, or this kind of thing. So you want it to supplement, like, okay, I'm not a Python expert, so write some basic code, but that's never gonna be as good as someone who's actually really skilled at Python, right? But is it enough to help me write test cases? Absolutely, right?
Yeah.
So this is the kind of, I have a colleague here who's doing a presentation on using AI to actually to observe other AI and to say, like, basically, how well is this chatbot performing? How well is this, like, also is it saying something negative or something really that could put your company at risk? You don't want it to be responding, so you need to be using something to monitor something else, which is an excellent use of AI, I would say.
Yeah. Let's check here if we have the same temperature on some stuff. I think it can be useful to talk about analytics on the one hand as sort of a creative and entrepreneurial activity, where you're exploring, you're not really sure what's going to happen, and you're iterating your way to some good solution. And then analytics as a sort of operational thing, reporting, that kind of stuff. And they're obviously related, but it can be worth sort of talking about the challenges of each respective one separately. Let's focus on the creative and fun one.
Yeah, agreed.
So, it's fun to think about the kinds of questions that you can ask now that you couldn't ask before. And so, let's pause the ontology thing for just a second. One of the things that, you guys have probably come across a lot of people that say, I want to be able to ask questions, but I don't know any SQL.
Right.
That's a pretty simple one, and nobody's expecting it to write perfect SQL, but we're not comparing an expert with an LLM. We're comparing a business person that never got to ask the question in the first place, isn't that right?
Comparing something with nothing.
Yeah.
Which is like, yes, you're already better off.
What is your experience with that kind of automation? Has it actually worked? Have you seen people using those kinds of things?
Yes. My experience is, my experience is a little like connected to what you said just a minute ago, is that you will typically see junior developers being more challenged by LLMs in terms of SQL than senior developers. Senior developers, they know their craft. They've been around for a long time. But junior developers, I think, unfortunately, or fortunately, at least they're being challenged by LLMs to a larger degree, right? Because what they write is a little more error-prone. And so unfortunately, they are challenged by large language models. Or luckily, I don't know how to phrase that, honestly.
I think it's okay to speculate. I mean, I consider myself a fairly good programmer, and I find a lot of utility in AI-generated code. And I leave it shitty sometimes because it
Good
saved me
enough.
so much time
Yeah, sure.
that
Agreed.
can't be bothered always. When I code for passion, I do it as slow as I want and as short, few lines as I can. But when I'm trying to get some stuff just pushed that is good enough, sometimes the AI stuff is pretty nice.
Yeah.
What about the accessibility with graph stuff? I have found that sometimes it's even difficult to explain to people what a graph is. They're like, why would I? I work at the National Public Television nowadays, and this woman was trying to explain to me how difficult it was for her to make a table out of the things. And I was saying that's because maybe it's more convenient to model it as a graph. One person can be involved in many things, and each thing can be related to another thing. It's a graph. And she was like, huh. And so I think it's a foreign concept to some people, whereas tables, they're more familiar. How has Neo4j sort of worked with having to teach people graphs?
Well, that's
And
a
has
good
LLMs
question.
made-
I'm still kind of struck by how many times I get that question, what is a graph?
Yeah.
And then I usually insert the word network.
Right.
Because, yeah, graph is just like an academic name. Sometimes it's easier to think about it like a network. You just have like different things connected somehow.
Right.
And then the applications for network is going to be twofold. I mean, one is the shape of the network itself. Can have certain traits. Like in the network, you can talk about like what is a central node, what is like a community or a group of things in the network, and different paths through the network, regardless of what data is in the network or what the network describes.
Yeah.
But then you also have like, when we start adding labels to kind of organize the nodes and organizing data and stamping data on those nodes, it gets like more complicated. But
I feel like with tables, people generally know how to filter stuff, pick out everybody that meets this criteria.
yeah,
Joining is a little bit more complicated, but they can sort of get it usually.
Yeah.
But with graphs, even filtering can be challenging for some people to conceptualize, not to mention stuff like subgraph matching and stuff. It's just, who's going to figure that out?
and unfortunately, I think it's one of those. It's like a habit we have, right? If you are a practitioner who have worked with data, you have learned how to kind of see the world as tables, and it's for good and bad. Because I mean, tables are great. Like you can kind of, you have these simple operations on them. You can filter, you can sort, you can kind of do selections, you can join it with other tables. But sometimes it's also working against us. It's actually easier to explain to someone who is not a data practitioner what a graph is. And why it might be a kind of a structure that is representing real world objects that is like super simple.
Yeah.
Than it is to explain that to a data practitioner that are so used to kind of putting things in tables and maybe have forgotten about that, there's a real world out there with objects that actually are connected or assembled together or have dependencies and rules between them.
What about at the other end, sort of data storage formats that are inconvenient for analytics? Unfortunately, we've let web devs decide way too much. We've given them too much power, and they've installed really dumb tools everywhere. But things like MongoDB and other stuff just have tremendous amounts of data in them. Is that stuff that you have to wrestle with, or is it native and you work with it easily? How has that sort of manifested itself next to traditional relational databases and tables and that kind of stuff?
I have to say, in my line of work, it doesn't come up so much, so I pass the ball to you.
Well,
I guess,
think,
maybe just to follow up, maybe it's because those kinds of databases are a little bit operations rather than analytics based.
Yeah.
But a lot of operations data would be great for analytics, which is why I sort of wonder, does that mean it's also shadow data? What were you going to say?
Well, I wanted to say two things. First of all, I want to come back to a little bit to what you said. Not to talk too much about graphs, but it's just because I come from not the data side. I have a background, a long academic background in library information science. I did a PhD in that field at the University of Copenhagen 15 years ago. But I knew metadata as a word way before a lot of people knew what metadata was. And I think graphs work really well at the metadata layer. So then I don't get confronted that much with that lacking understanding because it's very, very intuitive at the metadata layer. And then to connect back to MongoDB, I think the way I have only encountered it as a data source as so many others. So as at the metadata layer, you would be focused on extracting what is relevant to expose for all users across the company. And I really, really agree that, like, obviously you want operational data to serve for analytical purposes, obviously. So, I don't know. It's not a discussion that I've been having as intensively as you, I think. I sense that, but...
I think...
No, I think to add to that, I mean, it's... You say, like, yeah, documents is just another source of our tables or graphs if we're going to do analytics. But I think it's because, yeah, that's when we pivot from, like, what data structure do we need for the operational application and what data structure do we need for the analysis we want to perform. And if that analysis is of the type I want to just, like, do filters and aggregation, then, yeah, documents may work for that. If that is more, no, we want to do trends and trend analysis over time series, yeah, then maybe you need a different data structure. And if that is going to be, no, we're going to do a network analysis here because we need to understand how resilient the power grid is, and then, yeah, maybe you switch to a different data structure. So I think we will see different data structures being used and different database technologies being used in operational systems.
Yeah.
And we will see different, like, platforms and different processing frameworks and programming paradigms being used in analytics as well, because, yeah, depends on the angle of your analysis. And
I noticed that we got sucked back into the operations side of things again. But, I mean, the thing is, I've always felt that you want to design your data analysis for, like, the data that you're producing for data analysis. You know, just because you're producing lots of operational data doesn't mean it's actually useful for anything. And you sort of have to be mindful of what data you're producing, depending on maybe the kinds of insights that you want to extract from it. Which is why I was talking about graphs for a second, because maybe you start off with PDFs with images and just blocks of text, and you want to analyze it numerically somehow. What is a smart approach to that? And I think a lot of operational data ended up in Mongo. A lot of emails and PDFs end up on a blob storage somewhere. And there's lots of stuff like we know how to handle tables, and maybe graphs a little bit if you have, like, credit card transactional data that goes straight into Neo4j. But you know, nowadays when we're talking about data analytics, what kinds of new problems can we solve that we haven't been able to solve before?
I mean, I do think I have a couple of customers who have built, which they're very satisfying. They work very well. Setups where they're reading literally millions of documents and then have built conversational analytics on top of that. And where that to me has been just kind of groundbreaking, where someone can say, like,
on
yes,
its
this,
own,
and
that is
what
powerful.
about this?
Yes.
That was just data, as you had said, like, that was just hard to digest in a meaningful way before. So, like, text search is nothing on top of, like, just has nothing on top of the conversational analytics. So being able to kind of, again, ask something, but then also ask the next question.
Yeah.
That's one of the big, I would say, like, big changes on the BI side.
I want to hear, because it's sort of your area of expertise. I mean, one of the things that's sort of magic to me about LLMs is their ability to sort of cross over into semantic knowledge from just, you know, the data as is. And so, I mean, it's one thing to sort of text search and other stuff like that, and I just think it's very cool to be able to maybe guide LLMs into producing new data that maybe is easier to digest somehow. Is that something that people are incorporating into their data workflows now in order to wrangle data that was maybe hard to get a grip on before?
I see that, yes. I see that. But I also want to say something, like I was in Austin back in January, did a keynote at Data Day Texas. It's a great independent data conference. And I was the opening keynote, and I finally got to meet one of my heroes, Bill Inman, the inventor of the data warehouse. He's still around. We had
going
beers.
to conferences.
Yeah.
I also had the pleasure of meeting him in person because he do go to conferences.
And he's just a fantastic guy. And so we connected, and we're emailing now. And he came up with this term, the textual data warehouse, or the textual warehouse. He obviously invented the warehouse, the data warehouse, but the last many years he's been talking about the textual warehouse. And so here we are, finally. It's taking all the unstructured data of a company and trying to think, how can we utilize this? How can we make it available for analytics in ways that we have never ever imagined?
Yeah.
And so here it is. The large language models is kind of a, like, he talked about that for years and years before it really got very, very popular.
Yeah.
So obviously not the same thing, but the idea, the kind of questions we can ask, the kind of questions we can answer, it's just a completely new world, right? And I guess
what
the
you're
output
saying
maybe...
is having the semantic model with it allows it to, you also can communicate with the structured data as well. And
Well, I
knit
mean,
those
you're
together.
trying to connect the user to a data, and I think there's two parts to it. There's one is allowing the user to ask smart questions, and then there's sort of lifting the data up a little bit and getting closer to the user. I guess one thing I've been struggling with is setting expectations on what's reasonable to ask, right? So you index a lot of data, and okay, so in television, you index a lot of information about certain programs, and then the person might want to ask, okay, make me a new program based on this one, but like this. How is the model supposed to know how a program is designed to begin with? That knowledge, it's not privy to it. Like, if you have to treat it like a 15-year-old, intelligent, but maybe not so experienced. And, we have to put that kind of knowledge in. I didn't think that was necessary. And so, half of my work is trying to understand what they expect, meet them somewhere in the middle. I guess you must struggle with what's reasonable. After you've explained what a graph is, you have to explain what kinds of questions it might reasonably be able to answer.
Yes.
How do you approach that?
Well, that's a good question.
I mean, the thing I want to do is I want to give an LLM as a tool because nobody's going to take the time to learn GraphQL.
Yeah.
Yeah.
It's not that hard.
I know. Yeah, it is. To a journalist, come on.
It's hard enough.
It's hard enough. And just for that part, I think it's sort of neat. But even so, knowing what's a reasonable question to ask is still a challenge, even if you give them an LLM that can write GraphQL code for you. Maybe you just work with really smart people.
No, but I think it's like one of your, if you go back to your kind of, if you have a TV show or like what makes that good in the first place? Right? And it could be so much. It could be kind of you like the photography of that show or the setting or the scenery. It could be the characters. You could like that there's a lot of interactions between people. You could like the plot, that it's an exciting plot. I mean, it's one of those like, yeah, how do we, then we're back to some kind of very more kind of like, yeah, how do we learn what's important in data? Or how do we learn how do we classify what is like good for what person and what audience? And
well, maybe you guys have some experience with the difference between stuff that is quantitative at the source and stuff that is qualitative at the source, and then turning that into something that's quantitative so that you can do analytics on it.
Yeah.
What is your experience with that?
And I mean, basically we try to do that in a lot of analytics application with graphs because then maybe we have like data points like the ones I just described. Let's say you have the plot, you have the story arc, you know problems and you know characters and how they interact, and then you start studying that graph to see like, oh, this graph has this shape, it has these groups of things, and then you can compare it to another plot and maybe something stands out and that otherwise would be hard to find in the data, just based on the representation and how you choose to kind of model the data.
So we only were... Oh, apologies.
Yeah, and I mean, the most kind of trivial application of that is like when we work with like fraud or a fraud detection in financial transaction systems, right? Because then you would see that pattern that, this is how a normal pattern is, or behavior with like, in terms of how you move assets and money around, and this is something that looks not like the normal pattern, and then you investigate that further.
Right.
So we work at the metadata layer, and so the way we interact with the distinction between quantitative and qualitative data and how that connects to analytics is that at the metadata layer, it's quite fruitful to go back to the data sources and contextualize them with qualitative elements, even though they are quantitative data sources. That's quite fruitful, quite interesting, and easy, I dare say. And then on the other hand, we can also take this, I dare say, qualitative layer in our platform and then, or in our technologies, and then work upwards towards the use cases of agentic AI, AI assistants. I think it's reasonable to talk about assistants also in this context because people are always like moving full speed ahead, and that is super interesting. But maybe we should like focus a bit on even on like improved machine learning, generally artificial intelligence. So, and in that context, I think qualitative data or knowledge that really is structuring, for example, for an agent in terms of its behavior, it's just really, really gold. So, and that will obviously enable your company to move faster. And then, as the promise is, perhaps it will make SaaS applications go away altogether. Maybe. Let's see.
Well, we've probably seen precursors to this. You know, maybe something like sentiment analysis on user reviews on websites and stuff like that. You flag this one. I mean, but even then, imagine, is this user upset? I guess you could score it from 0 to 1 on how upset they are or not, but still, there's some kind of arbitrary level of from qualitative to quantitative that you make that jump. It's the same thing in fraud systems, right? You're saying this is how much risk we want to have or not risk, and how anomalous should it be?
Yeah, this is where the good enough gets
enough.
into play.
Let's talk about that for a second. Good enough stuff, something that I think is tremendously underrated. Everywhere, I think because people have pride in craftsmanship, generally, engineers. But is good enough good enough?
I love it.
I mean, it depends on the use case, right? It depends on what is the... Yeah, what goes wrong if this goes wrong?
Paying
Maybe
taxes,
it's the question.
it's never...
That's good enough. But then at least what I find is every use case has its own kind of sensitivity of like, and there's some use cases where like, I mean, if someone's recommending a wrong TV show, like, okay, I don't think that's the end of the world. But like,
let's tie it back to what we were talking before. I mean, we were talking about not doing anything at all versus doing something that's good enough as opposed to perfect.
I mean,
before we weren't recommending any TV shows.
Yeah, I mean, and I would rather have something recommended and then be like, okay, that's interesting. And at least it's always a funny story if it's recommending something incorrect, right? To be like, I'm not sure why I'm being targeted for this. But yeah, I mean, again, it really depends on, I would say, industry and specific use case of kind of like how risk tolerant you are.
I suppose in your case, sorry for singling you out as having the most challenging sort of concept to introduce. But I know so few companies that are working with graphs in operations or in analytics as I do companies that work with relational databases. Nevertheless, many of the use cases that you are involved in must be somewhat novel, just due to the fact that the tool maybe is newer than the relational databases.
Yeah, but I don't think graph theory and graph applications of graph theory is like super new. It's like we have, I mean, one of the most well-known algorithms is like PageRank, and that's like basically what Google invented when they kind of took over the whole internet search space.
Yeah.
So it's like, it doesn't need to be kind of super novel or kind of very kind of specific, but then of course, I
have to say, my come to Jesus moment with that was with a supply chain situation where we were discussing product substitutes.
Yep.
And it was just so much more effective to do it with like Network X than with SQL. And I was like, okay, all right, this is my first time. I'm like, all right, I'm really impressed.
Yeah.
7 seconds versus 15 minutes.
But
there we go.
interestingly enough, when speaking about analytics, it's like, it's that sometimes you kind of move what is considered like being a model that you need to train. Let's say for recommendations, if you're training a collaborative filtering model, that may actually be an operational query in the graph. because you can access like others that watch this show also watch that after, and that could actually be a reasonable pattern to traverse in the graph, where it would be kind of maybe an unreasonable thing to join in a tabular structure. So I mean, we do come across that. Yeah, some things that used to be kind of like training a model that has some unexplainable behavior can actually be turned into a query that is like very explainable and very predictable what it's doing.
Right.
And sometimes that matters, because I think on the topic of like what is good enough, isn't just giving a recommendation better than not giving a recommendation at all? Yeah, it depends on the domain you're in. When it comes to like tax or what was it, like social fraud in the social insurance system, and just singling out women is not good enough. It's like that's too biased, and it's like not responsible to do.
Yeah. No, I'm not. We don't have time to get into ethics now.
No, that's.
But let's hope that AI can save us from all the unethical people that are serving us in the government and in the private sector. That being said, I think when it comes to, we shouldn't get too stuck in graphs, but graphs are really damn neat. Some of the really complicated NP-hard stuff is still outside of reach for most people. Subgraph matching, I wish it was a feature in all graph databases. It's not. It's NP-hard. And the best chance we have of solving NP-hard problems outside of quantum computers is machine learning.
Yeah.
LLMs are a specific case of graph learning. Every step in an LLM is either a dynamic algorithm step in a loop, and the attention matrix is a graph Laplacian. So, it can probably find stuff that would just be too tedious for a human. I guess that's why we're getting back to this thing like, what can we offload to machines? And the ontology thing is, of course. Ain't nobody got time to make a perfect ontology and read through thousands of documents and do it the right way and do
No, that is correct. I agree. But I think actually I was thinking like at the metadata layer, I'm sorry to be talking so much about graphs, we should push forward also, but at the metadata layer, it's really the other way around. It's easier to explain a graph, and it's more functional to use a graph if we work with metadata to build a meta model of a company than to force some kind of static meta model onto a customer, and they can't recognize themselves in that universe at all. So actually, like working at the metadata layer is a little bit of a blessing if you work with graphs the way we do, because it's just so much easier. Anyway, just wanted to...
what kind of data is the most inconvenient? Just to take the opposite side.
As in terms of data source?
No, metadata management.
I simply don't. I think I follow the question in terms of operational data or like technical data. Or what are you thinking about?
I don't have anything in particular. I just want to hear. What customers really like is to hear stuff that goes wrong and stuff that's difficult.
Oh yeah.
Then they feel sorry. They're like, oh, it's not just me.
Yeah.
So I'm trying to figure out. You're saying graphs is very nice because it's very, very at the metadata level because it's very recognizable, very intuitive.
Yeah.
What is the opposite of that? Like, what is maybe some customers set up their data in a way that's very, very opaque, not intentionally, but just it turns out that way. What is your experience with sort of bad architecture principles then for doing analytics?
Static metadata.
Okay, so
structures that are unflexible. Avoid that at all costs.
Okay.
I would say any kind of whether you're looking at operational or analytics, anything that is like that is not flexible, where you can't adopt as changes occur.
We have 2 votes for static and inflexible.
Yeah.
What's
inflexible? I think inflexible.
I would say, like, what causes the most issues when you have something with really complex privileges on top of it? Because what that means then is someone is looking at something and saying it's equivalent to this other thing, and then it turns out they're not equal.
Oh.
And then nobody trusts anything with, good reason, but I would say this is where I see people running into kind of like deep challenges.
Just to check, are you talking about like access control stuff?
Yes, exactly.
Wow.
Which is, it sounds simple,
That's
but
the hot take I'm looking for.
it all
Access
comes back
control
to
is a
access
source of a
control.
lot of problems.
Oh, it is. It is.
It is.
See?
All right.
I agree,
I think
I
that was
agree,
a
I
strong
agree.
ending. Thank you.
Thank
All
you.
right,
so
everyone.
much.
Thanks for a great panel. Thanks, everybody, for listening in. And we will be back shortly with another interesting segment. Thanks, everyone.
Thank you, Robin.